In this video, we want to prepare a solution set for Imo State University Physics 102, that's the general physics. Now, the section is 2017-2018 section. So here we go. The first one says, show the ratio of electric and gravitational forces of attraction between electron and the proton in a hydrogen atom is independent of the separation between them. So we want to show that. So the electric force F, let's use subscript E. Electric force is giving us Q1, Q2, 1 over 4 pi S0, 0. Let's use x squared for the distance, according to Coulomb's law. Now, the gravitational force is giving us G m1 m2 over x squared. So their ratio, which is F electric force over gravitational force, will now be given as this over this. So Q1, Q2 over 4 pi E naught x squared over this, which is equal to this, G m1 m2 over x squared. So this is the same thing, this divided by this. So mathematically, we introduce multiplication and invert this, which will give us Q1, Q2 over 4 pi E naught x squared times, we now invert this, x squared over G m1 m2. And if we multiply this and multiply this, what we're going to have is Q1, Q2 x squared over 4 pi E naught x squared G m1 m2. Now here, these and these are common, so they cancel each other. What we have left is Q1, Q2 over 4 pi E naught G m1 m2. So since this is the distance of separation between them, they have cancelled out. You can see there's no longer distance of separation. So we've been able to show that. 1b says, draw electric field pattern between first one, a dipole, second one, two negative point charges close together. So for us to have a dipole will have negative charge, we have positive charge. So we have, so it will move from positive to negative. So this is positive charge, this is negative charge. Negative charge, so this is a dipole. A dipole. The next one says two negative charges. So if this is a negative charge, this is a negative charge. So this one goes this way. So this one, so since it's a negative charge, the direction will be in this way. So there's going to be repulsion. So this is two negative point charges. The repulsion is the result, so they will not get to each other. C says a flat plate having an area of 5 meters squared is rotated in a uniform electric field whose magnitude is 7.4 times 10 raised to power 5 Newton per coulomb. Calculate the electric force through this area when the electric field is 1. Perpendicular to the surface of the area, 2. Parallel to the surface, and 3. Makes an angle of 75 degrees. So we begin. So for C, we have that area is 5 meters squared and that the electric field is 7.4 times 10 raised to power 5 Newton per coulomb, and then we know that E, the flux, let's begin with this, flux is equal to E dot NA, which is also equal to electric field times area times cos theta. Now, since it is perpendicular, theta is 90. So we're going to have 7.4 times 10 raised to power 5 times 5 times cos 0, which will give us if we press it in the calculator, we're going to get 3.7 times 10 raised to the power 6 Newton meter squared per coulomb. Now the second one says when it is parallel. When it is parallel, it means there's no angle between them. Using the same, flux is equal to ENA. So is cos 0. So we'll have 7.4 times 10 raised to power 5 times 5 times cos 1, cos 90, which will give cos 90. If we press, cos 90 is 0, we're going to get 0.000 Newton meter second. The third one, still using the same, we now have angle of 75. What we now have is 7.4 times 10 raised to power 5 times 5 times cos 90 minus 75, which is 15. So if we plug in cos 15 and multiply out, we're going to get 3.57 times 10 raised to power 6 Newton meter squared per coulomb. Number 2 says, Radio Nigeria transmits music on a wavelength of 1,500 meters and frequency of 200 kilohertz. Calculate the velocity of the radio waves that carry the music. Determine also the frequency of the local program transmitted on a wavelength of 330 meters. Now, for us to get that, we know that the velocity is given as f lambda. So, which is, our lambda is 1,500 times our frequency is 200, but it is given in kilohertz, so times 10 raised to power 3, which is 1,000. So if we press calculator on that, we're going to get 30 times 10 raised to power 8 meters per second. The next one said frequency when it is operating. Okay, so we'll make f subject of the formula. F is equal to V over lambda. Now, which is equal to 3.0 times 10 raised to power 8 over 330, which gives us 9.091 times 10 raised to power 5 hex. The next question, B, says, why are capacitors classified as passive electronic components? Now, capacitors are passive components since they respond electrically to charges in a circuit that depend on 1, their configuration, 2, material they are made of. So, the next question says, prove that the electrical potential energy stored in the plates of a capacitor or the work done in charging a capacitor is U equals half QV, indicating the meaning of each term used in the proof. So for us to prove the work done in charging a capacitor, that is energy stored, is if we have U equals half QV. V is the potential difference and Q is actually the charge stored or transferred in charging from Q equals 0 to Q equals Q. So voltage across plates is given as V squared Q over C. Now work done, which is omega W, to transfer additional charge from omega sorry, delta, not omega, delta Q equals delta W is also equal to V delta Q. So this thing is equal to Q over C delta, because V is equal to Q over C. So we can substitute V as this. If we don't want to write delta, we can say sigma W is equal to Q over C sigma Q. So total work done, or total work that is done to charge from Q0 to Q to a small letter q to capital Q, that's energy stored in the capital plates, that's U. In the capacitor plates, U is equal to W, which is equal to, that's U, energy, is the same thing as work done, is equal to F dW, which is equal to 1 over C integral of from 0 to Q, Q d Q, and it's the same thing as Q squared over 2C. So if we remember that Q is equal to CV, or that if we make C subject of the formula, we'll get that C is equal to Q over V. For that, we're going to have that energy stored is Q squared over 2C. And also, if we remember that Q squared over 2 is equal to V over Q, in that case, we'll now arrive and have that it is equal to 1 over 2 QV. So that is the answer. This question says an electric fan draws 2 amps of current from a 240 volt source. Find the cost of operating the fan during the month of July if electricity is available 6 hours daily and 1 kilowatt hour costs 4 naira. So for us to get that, the current is 3 ampere and the volt source is 240 volts, and it is in the month of July. So remember, July has 31 days. So the number of days that that fan was operated was just the number of hours, 6 hours. 6 hours daily. So first of all, we'll calculate power. Power is given as IV. Our I is 3, V is 240, which will give us 186 hours. Sorry, this thing is 2 ampere, not 3. 2 ampere, which will give us 480 watts. But for the purpose of this topic, it will be in kilowatts, which means we are going to divide by 1000, 1, 2, 3, which is 0.48 kilowatts. So the time is 31 days times the 6 hours daily, 6 hours, which will give us 186 hours. And for us to now get the energy costs, energy cost is now equal to power times time times the cost. The power we got was 0.48 kilowatts. Okay, let's put it so that we can remember. Kilowatts times time. The time that we got, 186. Remember, it has to be in hours, not in minutes or seconds. Then the cost of it. From the question says that the cost was 4 naira. So 4 naira. If we multiply all through, we're going to get, calculator, we'll get 357.2. naira. The next question says, use a diagram to explain spherical aberration in mirrors. So if these are rays of light and they fall on different if this is the focal, this F, this is a mistake, so this one comes here and this one comes in a different place. So here is F1, here is F2. So what it means is that the final image is blurred. So this phenomenon, you have different beams that are parallel. So you form a blurred image. That's spherical aberration. That's why we define spherical aberration as a phenomenon where blurred or imperfect image is formed as a result of many focal parallel beams of light that strike the surface of the spherical mirror at various regions. Sorry, this line is supposed to be from here to this line. Two radio sets each of average intensity level 25 decibel are played together but tuned to different stations. Find the total average intensity of the sound heard. The total average intensity, let's say the total intensity I is 21. Now the level of decibel is 10 log 21 over I, which will give us 210 log 2 times log I over I naught. So that if we resolve here, we're going to get 3 plus 25 decibel, which total of 28 decibel. The next question says, draw a circuit containing 3 resistances R1, R2, and R3 connected in parallel with EMF source. Also show how an ammeter and a voltmeter can be connected to this circuit in order to measure current and potential difference. So for us to do that, we first of all place the resistors they are in parallel. Let's say they are in parallel, and this is the circuit. An ammeter can be connected here. So a voltmeter can be connected here. So here is R1, R2, R3. So here is positive, here is not negative. You need to note, very important, that an ammeter has very low resistance, and so because of that it is connected in series with the circuit. But voltmeter has a very high resistance, so is connected in parallel with the circuit. 4b says, state I, the physical phenomenon that causes refraction, and II, the effect of refraction on frequency. So the first one is that refraction is caused by the change in speed of light beam or light ray in the new medium. When there is change in speed in a new medium, so that's what causes refraction. The second question there, the effect of refraction on frequency. Now, the frequency remains constant during refraction, so it's not affected. 4C says calculate the magnetic force on a 240 meter length of a wire stretched between two towers carrying a 150 ampere current. The Earth's magnetic field of 5.0 times 10 raised to the power minus 5 Tesla makes an angle of 60 degrees with the wire. Now, the formula we are going to use is F is equal to ILB sine theta. Now, current is I. In the question, the current there is 150 ampere. Now, L is length. And the length there is 240 meters. The next one is the magnetic field. Earth's magnetic field given as 5.0 times 10 raised to the power minus 5 Tesla. So the next angle given to us, which is 60 degrees, theta 60 degrees. So if we say F, we want to now calculate it, F, I 150 times L 240 times B 5.0 times 10 raised to the power minus 5 times the angle, which is sine 60 degrees. So if we calculate this area, we're going to get 1.8. Then sine 60 is 0.8660. If we multiply this out, we're going to get approximately 1.56 Newton. 5A says that grammatically represents the formation of an image by a double concave lens when the object distance is greater than the focal length. So if we're going to do a sketch on that, so divide it into two. So let's say here is the focal length and the object is beyond it. So if the object stands from here, the ray moves, supposed to be at the middle, moves from the middle, passes in this direction, then this from here, light from here goes here, and so here is where the image is formed. So O is object, F is the focal length or focal point, not focal length, focal point, sorry, focal point. I is image, so you can see the image is erect, it is also diminished, which means it is smaller than the object. So you can see here that the object is after the focal length. 5B says the periscope is a simple optical device. In two simple sentences, state 1, the principle behind the operation of the periscope and its major application. Now, the principle of periscope is that it utilizes the principle of total internal reflection. That's what periscope uses. So the periscope is also used for viewing otherwise inaccessible objects, objects that are very far. That's what it is used, that's the application of it. 5C says the voltage output of an AC source is given by the expression V equal to 200 sine omega t. Find I the RMS current in the circuit when the source is connected to a 100 ohm resistor. So using the equation given to us that V is equal to V max sine omega t, where V max, let's say where V max is 200 volts, the V root mean squared is given by V max over root 2. which is equal to 200 over root 2, which is 141 volts. And the current root mean squared is giving us V over R. So V root mean squared over R, which is 141 over the R given to us there is 100 ohm. 100 ohm. If we divide it, what we'll get is 1.41 ampere. That's it. This question says number 6a, plot the instantaneous current IR and instantaneous voltage VR across a resistor as a function of time. What is the phase difference between the two signals? Now, if we plot both of them being a function of time, here we'll plot IR and VR. Here is time. So, if we go for V, then this for I, you can see here, this is the V max, here is the I max, so you can see both of them are in phase. Because of that, their phase difference is 0. Six B says, show from mathematical principles that for a sinusoidal applied voltage, the current always leads the voltage across a capacitor by 90 degrees. Now, if we first of all do a sketch capacitor C, we have V. Now, the voltage of the capacitor is giving us V max sine omega t. Now, if we use the formula that C is equal to Q over VC, we make Q subject of the formula. Q becomes equal to CV max sine omega t. Now, for current of that capacitor IC is change in Q over T, over change in T, which is equal to CV max cos omega T. So if we use trigonometry identity, we have that cos theta or cos omega T is equal to sine into omega T plus pi over 2, so that IC is equal to WC V max sine omega T plus pi over 2. Now pi is equal to 180, so 180 over 2 is 90. So because of that, current leads by 90 degrees. C says, an 8.00 microfarad capacitor is connected to the terminals of a 60 Hz AC source whose RMS voltage is 150 volts. Find I, the capacitive reactance, II, the root mean square current in the circuit. Now, we know that the capacitive reactance is equal to 1 over WC. So, but we already know that W is giving us 2 pi F. So because of that, we can see that W is equal to 2 times pi times the F given to us is 60 Hz. So if we press calculator to multiply it, we get 377 per second. So if we have 377 per second as this, we can now say that this is equal to 1 over 3, that's W, 377 times the C is given to us as 8.0 microfarad, 8.00 microfarad. So 8 times 10 raised to the power minus 6 farad. So which is 332 ohm. And for us to get the RMS current, the RMS root mean square current, it is given as V root mean squared over capacitive reactance, which is equal to 150 from the question, 150 volts over what we calculated before was 332 over 332 ohm. So I can put volts here, put ohm here, so that what you get is, if you divide it, you get 0.452 ampere. Number 7a says, with the aid of diagram, explain hysteresis curve of a typical ferromagnetic material. B says, distinguish between paramagnetism and diamagnetism. So if we have a sketch, and here from 0, let's say we have a sketch, and we have here is B, here is E, let's see, here is A, and here is BO, and they'll go here G, so we'll call here D, here is 0, so we can call here K. Curve OA shows initial magnetization of the ferromagnetic material until saturation is reached at this A. When the flux is reduced to 0, B has value called remanence. At this C. Because at this C, this remanence. So to reduce B to 0, we must forcibly disalign the domains by using a reverse external field. The point D gives the cohesive force needed to demagnetize the sample E. And this E is the saturation point in the reverse. So C2 is this 1 over 4 pi squared, 1600 times 10 raised to the power 3 because of the kilohertz, then times 5 times 10 raised to the power minus 3. If we press that in the calculator, we get 1.98. So the capacitor range is from 1.98 times 10 raised to the power minus 12 to 1.67 times 10 raised to the power minus 11 picofarad. So